Okay, so in this video, I'm going to talk about model building, and I'm going to talk about how you can use tools that have been made available in order to create models in a very simple and consistent way that in addition ensures that you don't run into any problems with data leakage. Okay, so we're asking, is there a smart way to build machine learning models? And as I basically just said, yes, fortunately there is. We say that we build a pipeline. So these pipelines, they can basically help you do all the steps when going from an input data set or from a tidy data set. We talked about tidy data in module 2, I think, to basically an output. So predicting the targets in a data set. We can also just what we can do is that we can use these pipelines to do some quite standard transformations. So that's basically pre-processing. So that's adding polynomials. You can impute missings, or you can rescale your features. You can do all these types of things in a pipeline. You can also do unsupervised learning, so for different types of dimensionality reduction, for instance. That's not something that we're going to talk about explicitly in this course, but it's something that you will see if you continue working with machine learning. And then it can also help you do this supervised learning part, or what's explicitly supervised, so really training a model when you have your transformed data set or your transformed features, and basically fit a model in order to make good predictions in your data. Okay, so what we have here is basically a visual representation of the pipeline. So as you can see here, there are two steps. There's step 1 and step 2. Step 1 is associated with the training data, and step 2 is associated with test data. So let's consider how these steps they work. So suppose, for instance, we want to rescale our data, then we would write both fit and transform in step 1. So we will learn the distribution of our different features in our training data set, for instance, and then we will transform them. What we do here in step 2, associated with test set, is that we only transform. So in order to ensure that we don't run into any problems with data leakage, we do not rescale the features to the distribution of the features in the test data. We rescale the features in the test data to the distribution in the training data. Then we can also conduct a dimensionality reduction, as I mentioned before, and then we can also fit a model to our training data set. Okay, but again, you can see here, for instance, when we fit a model to the training data set when we learn a given model that minimizes some kind of a loss, then we do not have any fit step here on the test data set, because we do not want to fit a new model when we work with the test data set. So therefore, we only do a transformation. Yeah. So I think this is slightly abstract, so I'm going to move on and show you how this works in practice. Okay, so first let's just briefly discuss what are the advantages of using a pipeline. So there are basically 2 advantages. So first, it ensures good practice. So as I was talking about here, we are only fitting any parameters to our training data set, and therefore we basically ensure there is no leakage from the test data to the training steps. And then in addition, as you will see in a minute, it just ensures that we have much less code when we work with machine learning, which can be a huge advantage. Okay, so what would this look like in Python? So in order to show this, I'm importing different things from the scikit-learn module. So I'm importing make pipeline from this pipeline here, and then I'm importing train test bit. You've seen that before from model selection, and then I'm importing polynomial features and the standard scaler from pre-processing. Okay, so what I'm showing you here is basically how I define a pipeline. So here I'm calling my pipeline pipe pre-process. And then in the way that I create this object is that I write make pipeline. That's quite intuitive. And then I specify the 2 steps that I want in my pipeline. So first, I want to make a polynomial transformation of my features. So by default, I think we're making a second order polynomial transformation. And then I also want to scale my features. And you can see that I'm doing this in the right sequential order, right? So first I'm making the polynomial transformation of my data, and then I'm scaling the features in my data. Okay. So we can also show you how the different steps show up in my pipeline. So I write pipe preprog, and then I write steps, and then refer to 0 and 1. So we can see that first I have this polynomial feature step as I had here, and then I have the standard scaler. Okay, so at this point you may ask, does this remind you of something? And maybe it doesn't, but hopefully it does. So this should remind you a bit about method chaining from pandas. So when work with data structuring in the first part of this module, we talked a lot about how we can reduce the number of steps that we are making with method chaining, where we basically have this line of code that make several transformations using different methods on a given data frame. This is a bit like the same, right? So we're basically just writing a pipeline here with very little code that allows us to do lots of different things here. Okay, so let's now try and apply this pipeline on some data. In order to show you how the pipeline works, we're going to import the Boston house price data. So we are importing that from scikit-learn with load Boston here. Okay. So what I'm doing here in the first part here is simply that I'm just printing some descriptions of my data set. So we can see that here these are some of the variables that we have in this data frame that we're importing from scikit-learn. So you can take a look at them if you want. You're also going to learn to work more with this data set in the exercises. Okay, so then what I do first is that I specify what my features are. So that's something I do by writing boston.data. So that I create an object called x here. These are my features, and then I specify my targets. So that's y here, right? I write boston.target, and then you've seen this before. I split my data set into a training data set and a test data set with this train test split function. Okay, there should not be anything new here in this step. Okay, so how do I then apply this pipeline on the data? So now I just define a pipeline again. I do the same as I did before. I create a pipeline that I call pipe preprocess and specify that I want these 2 steps in it. Okay, so then what I do now is first that I use my pipeline on my training dataset, the features in my training dataset. So I create this new object called xtrainprep, where I have used this pipeline. I write pipe preprocess and then write dot fit transform, and then I specify that I'm doing it on my xtrain. And then I also create a new object called xtestprep, where I'm doing something that's similar but slightly different. So I write pipe preprog, and then I write dot transform xtest. So I do not write fit transform, I just write transform. So by doing that, I ensure, for instance, that when I scale the features to the normal distribution, then I do not scale the features in the test dataset relative to the test dataset, but I do relative to the training dataset, right? So when you work with the test data, you only want to write transform, you don't want to fit. Okay. So what would this look like if we did not use the pipe? So then we would have more steps, we would have more code. So then we would have to specify this object poly transformation as the polynomial features here, and then SC as the standard scalar. And then we would apply these two functions or methods down here. So basically we get 4 lines of code now. So first we're applying this polynomial transformation on both the train data set and the test data set, and then we are applying it on the standard scalar on the train data set and test data set. So comparing to what I had before, I could do both of these steps once. So just had to apply it once on first the train data set and then the test data set. So you can easily imagine if we had 5 different steps, for instance, in this pipeline, we would save a lot of code by doing this. Okay.